questions, and the reason I'm doing that is I have only ever seen one final exam from 2742, but it did have some true-false questions on it, and none of his other tests ever have, but I figured since I saw that one and it had some, that we would practice with some. Okay, so let's take a look at these. In a sequential circuit, the output is determined only by the current inputs and not by any past inputs or states. So first of all, we need to know, what do we mean by a sequential circuit? Anybody have an answer on that?
Isn't it just like a flip?
Flip-flops are certainly used in sequential circuits, but that doesn't define
Well, a circuit where like it keeps on like when it's on, it keeps producing different outputs based on like the inputs.
Well, all circuits produce outputs based on inputs. I mean, that's what circuits do.
It's hard.
Maybe because
Okay, yeah. So it uses a sequential circuit means, what does the word sequential mean?
back to back to back.
Yeah, so things that happen in order. And so sequential means that the stuff that happens depends on stuff that has happened before. And so it has memory. Do you remember when he first started with flip-flops, he talked about memory? Or if you don't, he did. And so a sequential circuit depends on memory. It depends on what happened before. So is this a true or a false statement here?
True.
False. Okay, so the reason it's false, is because okay, this is it says determined only by the current inputs. Determined only by the current inputs and not any past inputs or states. So that's false, because it is definitely determined by past inputs or states. So false. Okay, a Moore machine. A Moore machine defines its outputs based only on its current state, irrespective of the input. True or false? Okay, so far you'd be getting 100% on zeros. So if the goal was to get 0, 0, 0, 0, 0, doing good. So Moore machine, remember, I always forget which is Moore and which is Mealy, but I'm pretty sure Moore is the one where the output, oh, wait a minute. Yeah, the output depends only on the input, so that one's true. True, false. Mealy machines can react faster to inputs as their outputs can change as soon as the input changes without waiting for a clock edge. Yeah, that one's true.
Can you explain that one?
Sure. So what's the difference between Moore and Mealy?
And so the more it depends on its outputs, like its outputs.
Mm-hmm. So the project that y'all just did, before you saw the new state, what did you have to do? So you flip the switches, and then you press the clock button, and then you see the new state. Okay, so a Mealy machine, you get the new state, like the new state happens a clock cycle sooner, because it uses the current inputs, not the inputs from the time before.
Okay.
And so a Mealy machine will usually will be like one clock cycle quicker, and usually have one less state at least. I mean, it depends on the actual machine, but usually.
So for Mealy, are like the inputs independent of each other?
Not necessarily. Every finite machine can be implemented as a sequential circuit, but not every sequential circuit is a finite state machine. Why do you think false? What is a finite state machine? Okay, that's as important.
Two states.
Mm-hmm.
Two states.
Mm-hmm.
That's finite.
So the example that we just had, that was just mentioned in case y'all couldn't hear on Zoom, was if we have a two-state machine and we're adding together two numbers, and this state is we previously had a carry, and this state is no carry. And I have two inputs. So my two inputs are A and B. And so if my inputs are 0, 0, and I have a carry, then my output is 0, 0, 1. If my inputs are 0, 1, and I have a carry, my outputs are 1, 0. If my inputs are 1, 1, and I have a carry, what is 1, 1 plus 1? 1, 1 plus 1.
Oh, yeah.
So 1, 1, 1, 0, 0. That's why I should have made this one 0, 1, 0. Okay, so, and if my inputs are 1, 0, that's the same as if my inputs are 0, 1. That's if I had a carry. If I had no carry and my inputs are 0, 0, what's my output going to be? What's 0 plus 0 plus 0? 0. If my inputs are a 0 and 1 and I didn't have a carry.
That'll be 1.
So 0, 1, and that would give me 0, 0, 1. If my inputs are 1 and 1, what's my output?
0, the carry of 1.
So 1, 1, and my output is 0, 1, 0. Okay, so this may not be the finite state machine you were thinking of, but this is a finite state machine that has two states. And the two states are representing whether or not the previous addition had a carry or not. And then what do you get by adding those things together? And now...
Oh, yes, essentially.
What's that? It does. Yeah.
So a finite machine is a type of sequential circuit.
So the answer is true because you've learned how to turn finite state machines into circuits. How do you do that? And how do you figure out what gates to use? And how do you get the expressions? Use the state table. So use the state table to come up with your Carnot maps, and then from the Carnot maps you get the expressions. And given any state table, you can come up with a sequential circuit. It might be quite complicated, and a lot of times you're better off letting Verilog or something like that come up with it for you. But you can do it. But every sequential circuit is not necessarily a finite state machine, because a finite state machine means you have states and that your output depends on your states and what your next state is. And so if your circuit doesn't depend, doesn't have anything to do with states, like just an AND gate or something like that, that's not necessarily a finite state machine. Okay, state minimization in FSM design is a process that reduces the number of states in the machine without changing the language it recognizes. Is that true or false?
What is like what?
Right?
It doesn't matter if you're using Verilog or another language. I mean, it's a technique that's independent of that. In digital logic, a flip-flop is a device used primarily for storing single bits of binary data and has no impact on the control flow in sequential circuits. Now, this is an example of a sentence can be half true and still be false. Does it store bits of binary data? Sure. But it is also used to control flow. Asynchronous sequential circuits do not require a clock signal to function, unlike synchronous sequential circuits. That's true. So remember way back when, a long time ago, you talked about latches? Yeah, latches are asynchronous. They don't require the clock cycle. A state diagram and a state table contain the same information about a finite state machine, just presented differently. True?
Yes.
A sequential circuit can be converted into a combinatorial circuit by removing its memory elements. So sequential circuits, combinatorial circuits, that's what y'all did in Digital Logic 1. So can you turn any sequential circuit into a combinatorial circuit by taking all the flip-flops out?
Yes.
Well, yes, but it won't do the same thing.
Yeah.
I mean, sure, I can do that, but that's not, I don't think that's what the question means. Can be turned into a combinational circuit if I said that does the same thing.
Like, so by combination, do you mean like just using OR gates and AND gates?
Yes.
How you-
Sure, if I take out all the memory elements, it does become a sequential circuit, but it does not do the same thing. So,
So it says from, but like, so when you look at um, how we see them draw with gates and draw it with gates, but
you're right, you could. So that's an excellent point. And so the point is, the point that was just made is the flip-flops are made with the combinatorial stuff. So you could remove them and then replace them with their actual design, and you could do that. Sounds like a lot of work, but that is an excellent point. You could do that. So,
that's why.
yeah, but this is I'm not responsible. This is not a real test question, and so for this one, I'd say kind of, sort of, maybe. You just kind of have a lot to say about it. If you just remove the memory elements, you got nothing because it's not going to work. If you remove the memory elements and connect together the stuff that's left, you've got a circuit, but it's not a circuit that did the same thing before. If you remove the memory elements and replace them with their equivalent made up of, AND gates or NAND gates or whatever, you can have the same thing. It'll just be more complicated. In synchronous sequential circuits, changes to the output occur at discrete intervals marked by the edges of the clock signal. That is true. So you have positive edge triggered and negative edge triggered. So that's correct. All right. Any questions on that? Let me check on Zoom. Nothing in the chat. Okay, I am going to stop this recording and save it and upload it and then switch into the other thing on the other computer. So just